Just like the previous exercises, the first thing we're going to do here is try and find the equilibrium potential sign. So now we have L plus and F plus. For L plus, since we have more inside the intracellular fluid, it's going to want to go outside. So it's going to look like this. Since more positive charge is going to leave the cell, it's going to become more negative. So the equilibrium potential sign is going to be negative 110. As for F plus, we have more on the outside. So that's going to end up going into the cell, making it more positive. So that would be positive 60 for F plus. The next step is finding the resting membrane potential. So now we have negative 110 and we have plus 60. And we multiply those by the permeability percent at rest. So we look through the problem, and right here it says the actual relative permeabilities are 80% for L plus, so that's 0.8, and 20% for F plus, so that's 0.2. So now we just multiply those two together. Negative 110 times 0.8 is equal to negative 88. Positive 60 times 0.2 is 12. So we just add those together. Is equal to negative 76 for resting membrane potential. The next part is finding the peak action potential. So we have negative 110 again and positive 60 for the equilibrium potentials. I multiply that by the permeability percent at the peak. So looking through the problem, at the peak action of the potential, 70% of the channels are open for F plus. So it's 0.70 here. And 30% of those are open for L plus. So 0.30. So we just multiply those together. Negative 110 times 0.30 gives us negative 33. And we have positive 60 times 0.70 gives us 42. And we just add those together. So 42 minus 33 is going to give us 9. So peak action potential is going to be positive 9. The next step is finding the total excursion. So total excursion right here is just the absolute value of resting membrane potential. So negative 76 will turn into positive 76 plus the peak, which is 9. So we just add those together. 76 plus 9 gives us 85 for total excursion. And the next part is we need to find the threshold. So that's going to be the resting membrane potential, negative 76, plus or minus the total excursion, which is 85, times the percent. So for that, we have to look through the problem again. So that would be 10% right here. So times 0.10. So when we're doing this problem here, since we have negative 76 here, we want to move it closer to 0. So we just have to add instead of subtract. So 85 times 0.10 is equal to 8.5. So 8.5 plus negative 76 will give us negative 67.5 for the threshold. Now, the last part that is different from the previous problems is that when you look at the exercise, it says here, after the peak is reached, channels for L plus begin to open, while those for F plus begin to close. This continues until 90% of the channels are open and only 10% of channels are open for F plus. So this entire paragraph right here, number 4, is going to be hyperpolarization. So the formula for that is pretty much the same as before. You just take your equilibrium potentials for L plus, which is negative 110, and F plus, which is positive 60. And you just multiply them by the percent permeability at hyperpolarization. So here it's going to be 90 for L, so negative 110 times 0.9, and positive 60 times 0.10. So right over here. So negative 110 times 0.9. So really this is just the same formula as before that we used for the resting membrane potential and the peak. It's just the same formula, but this time it's just hyperpolarization. And here we have 60 times 0.10 giving us 6. So you just add those two together. That's going to give us negative 93 for hyperpolarization. Okay, so now we have all the information to make the graph. So what we have is the resting membrane potential, which is negative 76. We've got the threshold, which is negative 67. We've got the peak, which is 9. And we've got hyperpolarization at negative 93. So now we just look back at the example. It takes 5 milliseconds to reach the peak of the action potential. So from here, we'll start at 0. It'll take 5 milliseconds to reach the threshold, first of all. And it'll take 5 more seconds, or milliseconds, to reach the peak. Let's see if I can... There we go. So after it reaches the peak, it takes 5 milliseconds to reach hyperpolarization. So this part right here means that it's going from the peak to the hyperpolarization. So at the 15 millisecond mark, we're going to be to negative 93. And also, it takes 5 milliseconds for this to happen, and then 5 more to return. So after hyperpolarization, 5 more milliseconds, it'll come back to negative 76. So once again, here we have the resting membrane potential, the threshold, the peak, the hyperpolarization, and the resting membrane potential. So for this particular problem, there is a depolarization because it's going towards the 0 mark. There is repolarization because you go from negative 76 and you end at negative 76. And finally, there is hyperpolarization because it does go below negative 76 at the negative 93 mark.